Hello everyone, and how's it going? Today we are going to discuss why most Django applications fail at scale. We know that a lot of projects, lot of products like even Instagram was initially built in Django. But when we go forward and try to scale these things, it fails. I'm also going to cover at the end of this video how we can actually avoid those failures and how do we actually handle those things like in case of big very multiple big companies who actually use Django since a very long time. Most of the big companies actually use multiple tech stacks, not are not consisting of only one tech stack, but we are going to look at Django today. What happens? First of all, we are going to look at handling concurrency. The thing that happens is when we are trying to scale, basically, Django is not able to handle concurrency at very high level. What happens is that it cannot handle uh, like if I give you an example in other projects or services or tech stack like node.js, what happens is we have an event loop kind of architecture which Django does not provide inherently. So to give you a very basic example, if there are multiple lines of code and I have an API call at this particular line, and when I get a call at this particular line and I have this another line of code, in Django, it will do the API call and will keep waiting at this particular line. Whereas in case of Node.js or something, it will move to other things which are not related, which are not part of that particular API call, and it will continue to grow. So in the sense, like let's say it is normally it's a very famous example. Think of this that there are chef, there are waiters. So what happens is when somebody comes to give an order, like our customer, which are API requests, the waiter will not actually uh, wait that that I will take one customer's request and then I will give it to chef. I will wait for the chef to complete the cooking, and then I give this cooked item to the first customer and then move to the next customer. No, it will keep taking the request from multiple customers who want to give their orders, and then whenever the food is ready, it will serve that. It will always give priority to whenever some food item is ready from the kitchen, and it will go and serve that to that particular customer. But in case of Django, what happens is it will take one customer's order, it will give it to chef, and it will keep actually waiting as long as that particular item is not cooked. That is why handling concurrency is not great for Django. Most of the services which are like scale heavy, or where we want to do something like high number of API requests, in that scenario we always prefer tech stacks like Node.js, or you can even say some other tech stacks like Go or something, or Next.js, which are built more in this direction. Even we can modify Django, like there are libraries out there which works better. That is Fast API is there, which has event loop architecture similar to Node.js. So even though it is in Python, it works much better with Django. Second thing, health check API fail. What happens in this scenario, and it actually happens at scale. Let's say that you have a Django application in which you have a health check API. It normally happens that when you are using KTS, whenever we use KTS, we will have some number of pods. It is possible you have a backend service and you have, like, let's say 30 pods running on production. What will happen is you have to serve the API requests, incoming API requests we have to serve, but we also have to serve the health check API call. But it is possible that sometimes your API calls the, like let's say you have financial or some kind of loan application backend service, and it is taking too much time to serve these kind of API calls. Like let's say you have one bad API call which is taking, like let's say 30 seconds, and you have an API and you have a health check API which has to be called every 15 seconds, and it will return a health check response. Or these numbers can be different as well, but this is just an example. So this will try to do a health check every 15 seconds, but this particular API is taking 30 seconds. So this particular API call means API call of your backend service is actually blocking your health API call. What this will do is this will crash the pod. Your pods will keep on restarting and your data will also be lost. The API request, whatever came to that particular pod. This scenario happens absolutely at scale. One of the way to handle this is that we can actually reduce the this particular time, means we should not have these kind of bad APIs. Second thing is we should fine tune our health check API frequency or timer based on like understanding our APIs. Like if we do have APIs which are taking 30 seconds, health check API should be called like every 2 minutes or 5 minutes, even though it is not a very good idea to have that high time of um, the health check API duration. But on the other hand, we should not have API calls which are taking 30 seconds. Next up is serializers. Serializers, uh, it can happen a lot of time that you know we have multiple layers of serializer. Like you call one API call, and that API call internally call or try to fetch data, or like let's say it is that you are drawing some kind of you are showing some kind of PDF to the user, and in this particular PDF you have to get data from 10 tables. Now when you have to get data from 10 tables, there will be multiple layers of logic. There can be some 20 serializers for that in worst case, right? These 20 serializers can span, like they can take 1 to 2 seconds in worst cases. And what will happen is the serializer itself will start taking a lot of time. And in case you're not aware, model serializers take a lot of time. After that, normal uh, method serializers take more time. That is why it is highly likely that this can happen, that at scale you are calling an API and there are multiple levels of serializers, because of which you are not able to actually get your data in time, and your APIs might also start timing out, or your API response time will spike a lot. Right, so how do we handle this? At particular scale, we actually try to skip serializers even in Django. Yes, so we try to keep serializers to a minimum, like whatever at the API response level, and we try to avoid multiple layers of serializer, like serializers just to fetch data from DB. We try to avoid that. And even if you want to format your data, so normally even for formatting the data, sometimes folks use serializers. Try to avoid that. Just to format the data, use a simple builder class. Then next up, we have the ORM. Django has one of the most powerful ORMs. You will see that there are languages like Go. There is other frameworks of Python also, like Fast API. They do not have a ORM as versatile as Django's. In Django, you can write queries very easily. You can have a table and you can access, you can have the get, put, filter, you can do any kind of queries directly on the model. Model is the table in Django. But there are also limitations to that. What happens is that this conversion, that we are using the ORM, and in turn it is converting it to SQL. This small amount of time that it takes, this particular layer that it takes, it might be a very small fraction of time, like even 1 ms initially. But when we try to scale our system, this 1 ms costs a lot, and this can even become very huge over a very long period of time. or you can say that when you have multiple db calls, you can have a very complicated system at scale where you are even making 100 db calls, and that can result to like a lot of data, lot of latency being increased. Next up we have, which is a very problematic thing, and I will also tell you the solution: indirect dependency. In case of other languages like Golang, or you can say even in Node.js, what happens is that we not only we track the dependencies or requirements for a project, we also track the indirect dependency. So what do I mean by that? So like let's say you are doing some particular operation, or you in which you have to show a form to the end customer. Let's say you install some library for that particular form to show that login kind of form. That login form installed another, let's say some time related library, which in turn installed some other mathematical maths library, let's say. Now what will happen is you just wanted this form library. In case of Django, it will track only the form library. But in case of other tech stack like Golang and Node.js, they will track all the indirect libraries as well. In most of the tech stacks, like even in Java, it tracks indirect dependencies as well. But in Python, we have a single requirements.txt file normally, in which we track only the direct dependencies. This can cause a lot of disturbance during deployment when you take things to production, because we are not locking the versions of the indirect dependencies, right? It is possible that sometimes it's version 1.0 is installed and some other time it is 2.0 installed, because we do not specify the exact version. We only specify the exact version for the form in our direct dependencies. How do we handle this? There are multiple ways. Either you can write, or what you can do is whenever you are installing a library in Django, you can do a pip freeze. You will get the list of all the direct and indirect dependencies, right? And then you can copy that into a requirement.txt, or you can use poetry, which is built exactly for this purpose to track the indirect dependencies. Cool. Next up we have is the n plus 1 queries issue. It is very common in case of Django because it uses ORM very heavily. That I will just give you an example. Like let's say we have authors and we have their books. What you basically want is you want uh, books of all the authors. So let's say you have n of this and you have m of this. What you will normally do is iterate over all the authors. So let's say if you have 50 authors, you will iterate over the 50 authors. For each of those authors, you will query the books, right? Let's say there are let's say 100 books. 100 books. So you did one query to get all the authors, the 50 authors, and you did n queries. Matlab 1 into 100. One query to fetch all the authors, and then for each author, you did a query to fetch the books. That is how you end up having n plus 1 queries. In case you would be writing a raw SQL query for this, we always handle this. But in case of ORM, it is very easy that you are a beginner or a junior developer and you end up with this kind of problem. Obviously, Django provides us solutions for this. You can always write advanced queries in Django related to select related and prefetch related. I will also tell you the difference between these in our future course videos. What is the difference between select and prefetch? But there are a lot of advanced queries. You can use outer ref and annotations and other things. But we can handle this kind of scenario and we can reduce this to a single API call. matlab fetching the books and all the related authors in the single API call. Next up, point is, if there are so many issues with Django, how do we actually use Django at production grade level? Let me answer that. Whenever we are using Django, like I will explain this a bit more. Like let's say we have a backend service which is primarily in Django. We need to use some other, uh, you know, other supporting stacks as well along with it. We need to use Redis basically for you can say for multiple things, for your session management, because Django provides you in-memory session management without Redis. If you use Redis, it can use Redis for session management or even for OTP and caching and other things, right? Or even when you apply rate limiting, it can do that in using Redis instead of its in-memory rate limiting, which is not the best way. Second thing is Django comes, very supportively with a DRF, Django REST framework. So you can have HTML files with Django directly supported, but that's not the best way to use it. You should use it along with DRF. Uh, and you should have your front end in a separate kind of tech stack like React, which is, very performant and single component, sorry, single page application. We just define multiple components and use that. I will talk more about React also in future videos. But for this, we do this. Plus, we handle async jobs separately using Celery. Again, we can use a broker for this like SQS or Redis, something similar. We also use cron for repetitive tasks. We do not need any additional library. We just need supervisor, which is provided by Linux machines, which is very handy. If we use all these kind of things, then it makes much more sense to use Django, right? So let me like create a much more clean diagram for you. Like let's say we have customers here, we have our backend here which talks to our DB, and any kind of async jobs if we get, we provide it to our async pods using Celery. If we have to do any kind of caching, we use Redis for that. But customer will directly be calling to backend, and backend will be based on like what it has to do, it will be delegating it to the querying the DB or the cache and or putting it to Celery. Celery async task can again talk to the database or Redis if required. So that is how we deal with Django at scale and avoid the failures. I think that's it all for this video. Let me know in the comments if you have any kind of questions, particularly to Django, or if you are facing any kind of problem with Django, let me know in the comments.